What we're doing in airspace today is putting airplanes on the equivalent of railroad tracks. So as we have rail operations in busy rail stations that come in and out of those rail stations on rails, that's essentially what we're doing with these airplanes. We're putting airplanes on predetermined tracks, and we're coordinating the flow of those airplanes using time, just as the railroad operations use time today to coordinate the sharing of the rails with the trains and the in and out of the movements of the station with trains. We've not been able to do that before in aviation because we've not had the ability to precisely position and track airplanes in and out of the runway, or off and on the runway. And so this is a significant change to be able to bring that level of precision and synchronicity into airspace operations that we've enjoyed for so many years in the less complex world of rail operations. We published a report in April of last year. It's called the Highways in the Sky Study. And we identified 46 airports that are of this lesser traffic qualification, more remote areas, or not necessarily remote, but certainly less traffic density. There's 12 different airlines that fly to these that are already fully equipped. The pilots are trained. And so we did a study. If procedures were put into those airports, those 46 airports, the economic benefits would be $65 million per year, 747 days of less flying time for the traveling public on airplanes flying to those, 13 million gallons of fuel not burned, and of course all the associated emissions with that. So this is our intent as GE, is to build this capability internally. We've worked with the FAA. We are now qualified as a supplier to the FAA to deploy flight procedures into the U.S. airspace, and we're looking for that opportunity to come alongside the FAA and assist with this deployment. It only makes sense, with the challenge as big as it is, to use all available resources, and GE has invested quite a bit, and we have a lot of capacity to help.